And next is the another problem of finding the least radius of the gyration. You have to find it. So in order to find out the least radius of the gyration, you have to find out the moment of inertia I. If you find out the I, you can find out the least radius of the gyration. Okay. I will tell you later how to find out the least radius of the gyration. Okay, so least radius of the gyration for the given shown section you have to determine. So this is the given section. Okay. See here, you can see here very clearly. Here the height is 120 from outer to outer, from here to here it is 120. Okay. So next the from here to here length it is given 180. Here thickness is 10, here thickness is 10, but here thickness is 12. Okay. So what you have to do is you have to make a section. Okay. Rectangle section. You cut like this and you cut like this. Okay. So here it is a 10 and here it is a 10. Total height is 120. So you can make it as 100. Okay. So that will be convenient one. Okay, it will be one rectangle one, and here the another rectangle. Okay. So here it will be another one rectangle. Okay. So finally you will having the two rectangles. Okay, three rectangles here, 1 2 3. Okay. See here the whatever the given section was there, here if you cut exactly here x center here and here, you fold either like this, half wherever the half this section is there, like this, either you fold like this or you fold like this. It is not symmetrical either in x axis as well as the y axis. Okay, it is not symmetrical. Okay, so that's why. So you have to find out the x bar and y bar. Okay, so you need to determine both x bar and y bar. Okay, both you need to determine. Okay, so in order to determine that, what you have to do, just use three sections are there. So use the formula ax1 a1x1 plus a2 ax2 a3 x3 divided by a1 a2 a3. Okay, this formula you use it. Okay. Take a individual section. You take this one as the first section, second section and third section. Okay, so area it is 180 is there. Okay, thickness it is given as how much, 10. Okay, so that's why 180 into 10. Okay. So exactly here now you have to you're finding with respect to x. Okay, so if you determining with respect to x means, see here you have to take a reference axis. Both, if you're finding the reference axis, finding the x bar means you have to take it as here as y. Okay, so this will be the y. Okay. And this will be the x bar. Don't forget. Okay, you have to take a reference axis. So this is x. Okay, here this line. Okay, x axis is known as xx bar, xx reference axis. This y axis is known as y axis. Okay. If you cut exactly at the center, okay, exactly at the center, actually from here to here, the length from here to here, the center will lies exactly here. Okay. So the distance, x distance to reference axis. Okay. So you are finding x bar now. Okay, x bar you are finding. So x distance. So center of this first section, this is the first section, this is the second section, and this is the third section. See here, this is the first section, this is second section. Okay. So this will be third section. Okay, clear? So for the first section, see here, this from here to here it is the first section. Okay. Exactly, if you center will exactly comes at exactly here, from here to here the distance will be 180 divided by 2. Okay, 180 divided by 2 is 90. So x1 is 90. Okay, here it is 90. Okay, next second area is see here total height is 120. Here the 10 will be deduction. This thickness whatever it is there, if you minus 10 mm, so it will be start from here to here. So here also 10 mm it will be reduced. So total length if you take it, if you take from year to year, it is 120. Okay, but you are taking from here, no, from here to here you are taking, so you have to minus this 10 mm as well as this 10 mm. Okay, so 20 mm if you minus from here to here, it will be only 100 mm. So 100 mm divided by 2. Okay, now the reference axis will be from here to here. Okay, got it, from here to here reference. Okay, because center will comes here, so the thickness is 12, so this is x2. Okay, x2 will be 12 divided by 2 because centroid will comes exactly at here, exactly at the center here. Okay, so we are finding x distance, no, this is x1. Okay, for the first area, so this will be the second area, x2. Okay, so that will be thickness 12 divided by 2 is 6. Okay, so that's why centroid will be 6. Area will be 12 or 12 into 100. Here 10 mm, here it will be minus, here 10 mm will be minus, so it will be 12 into 100 will be the area. Centroid will be 6. How means 12 is there, no, divided by 2 you do it, from here to here it will be centroid. Okay, so here also the third area whatever it is there, from here to here you have to take the x distance. Okay, so what is the x3 means? X3 is nothing but the total distance is 120. 120 divided by 2 is 60. Okay, so that's why x3 is 60. Area is 120 into 10. So thickness is 10, the length is 120. Okay, that here it has been cutted. Okay, so this is whole length, this is the whole length you have to take it. Okay, for the x3, so 10 into 120, area is 10 into 120. Okay, so whatever inside the area whatever it is there, here this one and this one is the area, you have to bring it to downwards. So take this area 1 and add. Okay, area 2 you take it from here to here, add it, and here to here you add it. Okay, so 3 area will get it. So finally if you calculate this one, you will get 57.429. okay, so that is for x2. Okay, same for like that you have to find out the y bar. Okay, y bar is the distance, so it is the distance like this. Okay, center to from here to here, it is the from here to here it is there, it is y1 for the first area. From the center from here to here you have to take it, so this is the y2. Okay, so another will be from the center. Okay, here from center to reference axis, to the reference axis where you will get it now, from here to here. Okay, so this will be the y3. Okay, so every centroid of the section to the reference axis distance you find it, that will be y3, y1, y2 and y3, that's all. Okay, so whatever the here area 1, area 2, area here formula, area 1, area 2, area 3 is there, no, same whatever you have written here, the same thing you copy, but only changes will be the y1, y2 and y3. Okay, these three will be changes. Okay, y1 is nothing but it is the distance from always it is the distance from here. Okay, from here to here. Okay, from reference axis to the centroid of first section. Centroid of the first section will exist here. Okay, centroid of the first section here exist here, so this distance is y1. Okay, so here thickness is 10 mm, 10 divided by 2 is 5, so y1 will be 5. Okay, see here y1 is 5. Okay, next y2 you have to determine. Okay, see here y the section starts from here to see, from here to here. Can you see here, here to here, because whatever the section is there we have cutted here and we have cutted here. Okay, this is one separate piece. Okay, separate piece, and this is another piece. Okay, in the second, the total height is 120. So here 10 and here 10, if you minus, it will be remain only the 100. Okay, so 100 divided by 2 is 50. Okay, 50 from here, 50 from here plus here 10. So here 10. Okay, so totally 60. So y2 is what? 60. Okay, got it? Because center, so to year it is 100 divided by 2 is 50. So that's what year 50 will arises here. Okay, from here to here it is 50, from here to here it is 10. So totally y2 is 60. So that's why y2 is 60 here. Okay, next is y3. Okay, see here, from here to here it is what? 110. How it 110 will comes means, see here, from here to here it is 120 and minus of this thickness, if you do it, it will be 110. Okay, so I will write it here. So from here to so from here to here it is 110. Okay, but I need exactly at a mid. Okay, because centroid will exist at the mid here, no? Okay, here it will exist. So 10 divided by 2, so that is mid. This height is 5 mm. Okay, so y3 will be 100 plus 5. Y3 is equal to 100 plus 5. So centroid will of the third section will exist here. So till base it is 110. From here to here it is 5 mm. So 110 plus 5 it is 115. 115 is the y3 distance. Okay, so that's why here y3 is 115. This is y3. So y3 is 150. If you calculate this, you will get 52.143. Okay. So finally you got the x bar and y bar. So x bar is 57.429. Okay, so from here, so we have taken this one as an x-axis, so this one as an x-axis. Okay, so this one as y-axis. Okay, you have to assume that this is y, this is x. Okay, got it. So in y, x distance at a 157.429. so from here to here, so exactly 57 now. So totally this is 180. So 90 means it will come here, 57 means it will come here. Okay, so 57, exactly 57 from here, 57 from here. So you draw a one line. Okay, so draw a one line. So this distance is 57.429, 57.429. so this is x bar. Okay, so like that y bar also 52. so from here it is 52 from here. Okay, so 52 it will come. So 120 is here, 60 will be here, 52 you take it here. Okay, so exactly from here to here. So this distance, this height will be the y bar distance. Y bar distance will be the 52.143 mm. Okay, so x bar distance and y bar distance. Okay, clear? So so first you have to find out this. Then what you have to do is very simple. Then you have to calculate the ixx and iyy. Okay, so if you find that, rest of all the things are easy. How to find out ixx and iyy is use this formula. Ixx is equal to summation of I plus area into d square. Okay, use this formula. Area first, what is the summation means? For first one, bd cube divided by 2 you take it. I is nothing but the moment of inertia of the single element, area of the first element, and the centroidal distance. So center of this first element to centroidal axis distance. Okay, so whatever it will comes, you have to take it respective one. Okay, so that will be the perpendicular distance. So whatever, see, if you are finding the centroid will comes here means the from here to here the distance you have to take it. Okay, that is for x bar. So if it is you are finding for y bar means y distance you have to find it. Okay. So that every time you take it that perpendicular distance. Okay. See, let me see how we will go how we will solve that problem. Okay, see here, this is the first area. Okay, so here they have written the area, the whatever the area is there, area you write it. Okay. And they have written column wise, you no need to write it as column wise. Okay, just write this formula. Okay. So ixx and iyy, summation you write it. Okay, individually you have to take it one single area and you have to do separately. Okay, see, now I will do it for ixx. Okay, see, now I will do for ixx. Okay, first area you take it, first area you take it, first area it is 180. This is the 180. From here it is a 180. Okay. It is 180. From here to here it is 120. Okay, don't forget, here to here it is 120. So this is the height. Okay, here. So here it is 10 mm thickness. Okay, here also 10 mm, but only this one is 12 mm. Okay, so this one is 12 mm. So what you do is you take the area first. First is bd cube divided by 2. No, just you expand it. Okay, so this formula is there. No, you just expand it. So what is that? I plus area into d square. This is the first area. I means bd cube divided by 2, 12. So that's the formula you have to use it. This is for first section. Again, second section will be there. I2 plus area 2. Okay, this is for area 1 for the first section. This is for I2 plus, okay, I2 plus area into d square. Okay, so this is for the second area. Okay, so this is for first area. Okay, this is for first area. The another will be, it will be continued. Okay, so plus I3 plus area 3 d square. Okay. So this, you remember the formula, just whatever it is there you expand it. I is a common for everyone, for every section. I, for if it is a perpendicular you have to put it as bd cube divided by 12. Area, you whatever area is there you add it. So d is nothing but perpendicular distance, that is a perpendicular distance from centroid to centroidal of the section. Okay, see here, the whatever the centroidal you have determined now, this is called centroidal. Okay. So centroidal of the section. Okay. Centroid is this one. Okay, centroid of this section is g1. Okay, g2 is the centroid of the second section, g3 is the centroid of third section. Oh, so the centroidal distance, the distance from the centroid of the particular section to the centroidal of the whole section, this whatever the dotted lines is there, it is the centroidal of the whole section. Okay, got it? So you have to expand it each time. Okay, so for the first section I will write it simply. So that is I1 plus what is that, area into d square. No, so I1 is nothing but bd cube divided by 12. B, you take this one depth, you take this one as a breadth and this one as a depth. Okay, for an x-axis. Don't forget this for an ixx value. Okay, there you have to finding ixx and iyy. Now, so ixx formula, you take this direction. Okay, this direction as b. Okay, got it? And this direction as d. Okay. Clear? So 180 is the b and thickness 10 is the d. Okay, so I1 is 180 bd cube divided by 2. No, so this one 180 is the b, d is 10. Okay, so 10 cube divided by 12. So if you expand this formula, if you expand this, I is nothing but bd cube BD cube divided by 12 plus area into d square. What B is there now, so I have taken this one as a B as 180. Okay, D whatever it is there, depth, that is 10. Okay, 10 cube divided by 12 plus area is what, B into D. B is 180, B is 180 and 10 is the A. Okay. Now, so the distance, perpendicular distance, whatever it is there, see reference axis is here. Okay, earlier when centroidal axis, when we are finding the centroid, we have taken extreme bottom corner and extreme left hand side as a reference axis. Like that only you have to do it. Now when you're finding the moment of inertia, the centroidal axis, you will get centroid distance, you will get it now, centroidal of the section. So this one, as you have to take it as an x-axis, this one you have to take it as y-axis references. Okay, so now say every time what you have to do is, where the section centroidal distance you will get it, from there what is the distance you will get it now, the centroid of this section. Okay, centroid of this section to centroidal, so what the distance you will get it, that one you have to take it as D. Okay, distance D. Okay, perpendicular D is nothing but perpendicular distance from the centroid of the section to the elemental section to the centroidal axis. Okay, so this is the centroidal axis. So for this you have to take it. Okay, so for the first section, from here to here it is the distance from here to here, the total height from here to here, it is 52.143. okay, so that 52.143, if you minus this 5 from here to here, it is thickness, it is 5, the total depth is 10, the centroid if you divided by 2, if you take it, so 5 from here to here it is 5. Okay, okay, from here to here it is 5, you have to minus with 5. Okay, 52.143 is there now, minus with 5 you do it. Okay, so minus with 5 you do it, so 52.14943 minus 5, it is 47.143. okay, so that's what it is been written here. Okay, that is the D1. okay, so our here it is there written as R. okay, here it is D, it is what, 47.143 square. okay, so that is the whatever I plus AD square is there no, so I is nothing but BD cube divided by 12 plus area into D square. So this is for the one section. For the first section I have done like this, so like that second section and third section also you have to do it. Okay, like that only. See here whatever I have written here, so that is written here. 180 is there, 180 into 10 cube divided by 12, 180 into 10, 180 into 10, so 47.143 is there, so square I have written as it is. Okay, so like that second section also you have to take it in this direction as a B, so that is 12. okay, so height is here to here it is 100. okay, this height is 100, so 12 into 100 cube divided by 12. okay, so whatever you have written here, so remove the cube, 12 into 100 is there no, just write it as it is. okay, that will be area. okay, so now you have to take it, find out the centroid. So we are what finding, you are finding like this. okay, so like this we are finding, so centroid will exist at the, see here this distance is what, 50. The second area, how you have to determine the second area is very simple. See here the centroid G. So first you find out the G distance from here to base. okay, see here from here to here it is 10. okay, count it from dotted line whatever it is there, from here to here, what is the distance, you have to find it. The distance is from here to here it is 100. okay, from here to here it is 100 divided by 2 is 50. okay, from here to here it is 50, so here to here it is 10, so total it is 60. from here to here it is 60, so 60 minus, if you minus with 52.143, if you minus you will get 7.857. okay, so that is what, so just what you have to do is, here to here the total length from here to here it is there now, from here to here, so here to here length you find it and minus with this. okay, then you will get this height. So what the centroid is there, centroid to reference axis distance is D. okay, so the D is 8.576, so that's why here 7.857. okay, so that's it, it is the D D2 square. okay, So next, third one is this one. Okay. So total height from the base of this third element to here, it is 110. Okay. So this height is what? 100. This thickness is 10. So it is 110 plus 5, 115. Okay. So totally height from here, it is 115. Okay. 115. So we need from here to here. Okay. The total height from bottom, from this here, okay, from this bottom to here, it is 115, but we need from here to here, no, but we don't need this one. Okay, so just minus with this 115 minus 52.143 is there, no, if you minus that, you will get 62.857. so that's what here it is, they have done 115 minus 52.143. so here order is changed, don't worry, but here from here to here height is 115. so 115 minus from here to here, you minus that, if you minus, so you will get from the centroid to centroidal distance. Okay, so this perpendicular distance from the centroid of the third element to the centroidal axis distance, you will get it, so that is d3, so that is 62.857. so it is perpendicular distance. Okay, so this is for the in the direction of y. Okay. So that is what you will get. If you calculate that, you will get ixx, all this you calculate. So ixx, you will get it some value for around 9.8407, you will get it. Okay, next we will find out for iyy. Okay, this is, see, if you are finding xxx, so perpendicular distance you have to get it. So perpendicular distance in the y direction, you will get it. Okay, so you are finding ixx, so ixx moment of inertia in the x direction you are finding, but you are finding the perpendicular distance d. Okay, d will be y in the direction of y. so like that, when you are finding iyy you are finding, so x distance, so centroid from here to centroidal, this is the y axis is there, no, from here to here distance you have to take it. so next another centroid will exist here, from here to here distance, this one you have to take it. Okay, so from here to here, this distance you have to find it, where the centroidal is there. so next is reference axis is this one, where the centroid from this line, where the centroid, either this centroid will comes in the left side of this line or right side of this line, so you have to take it that respective perpendicular distance, that's all. See, I will show very with some references. Okay, see, this is the centroidal axis, means if the centroid of any element, okay, this is the element. Okay, for this element centroid will exist, for the this element is here, like that, centroid of this element will exist here, centroid of this element will exist here. Okay, like that, if the centroid element of the and centroid of the element exist here, means, so this perpendicular distance you have to take it. Okay, if the centroid element will exist here, means this distance you have to take it. Okay, for this reference axis, the same way here. Okay, the same way for the centroidal axis, if the centroid point is exist here, means you have to take this distance. Okay, that's all. If the centroidal point of the section, if you exist the reference left side of the reference axis, means you have to take this distance, that's all. This is the distance you have to take it. Either reference axis is here, means either point lies in the left side or right side, respective distance you have to take it, that's all. Same way, reference axis is here, the point either come here or here, wherever it let it becomes, you just take the perpendicular distance, that's all. Okay, see here, next you have to find out iyy, you have to find it. Okay, so iyy, there is a 3 section, I1 a into d square, I2 plus a for the second section, I2 plus a2 into d square. For the third section, it is I3 plus a3 into d square. Okay, so this is for the first section, second section, third section. So here I told for the ixx, you have taken this one as a b and this one as a d. Now you should take this one as a d and this one as a b. Okay, so I is nothing but bd cube divided by 12. So you have taken this one earlier, you have taken this one as a b. Now you have to take a d, this side as a d and this side as b. Okay, bd cube divided by 12, no, so b is 10. Okay, so d is this one you call it, you should call it as d. Okay, this one you have to call it as D. So D will be 180. Okay. So 180 cube divided by 12. Okay, I1 is over, area whatever it is there. So sorry, this is 180, no? Okay, 10 into 180 cube divided by 12. Okay, so this is I1 is over, whatever you written here, simply as you write it as it is, 10 into 180. So you got area. Okay, area A1 is over. D distance is nothing but the distance here it is there. So you have to take, I told you are finding IYY means in the direction of x, your perpendicular distance you have to take it in the direction of x. Okay, so centroid is existed here. Okay, from here to here distance is, you have to, from here to here distance you have to find it. What is the distance? You have to find it. So here to here distance, see here, this the total distance is 180. 180 mid you will get 90. So 90 minus 57.429, if you minus, you will get 32.57. so this is D1. Okay, so you have to take it IYY means in the direction of x, in the direction of x, perpendicular axis x you have to take it. Okay, so D will be the what is the D? 32.57, 32.57 square. Okay, so this one is the first section is over. Okay, next you take the second section. Second section I told you have to take it, this one as a D and this one as a B. I have written here. Okay, once if you take it B in this direction means another time you have to take it D as this one. Okay, XX means you have to take it this one as a B, IYY